Remember this one, this wheel rotates with a constant angular acceleration. So we just use that formula for constant acceleration for 1D motion. But here, velocity just change it to the angular velocity. So the velocity at any point, just the velocity at the initial point, plus the acceleration times t. Okay? So the initial velocity, initial angular speed, or just this one, 120 rpm, but we need to convert to radians. So it should be 120 times 2 pi divided by sec d. This one you got radius per second, then plus acceleration 4.188 times the t, just 2 seconds, I tell you. Okay, so the whole thing you get the speed at that point should be 20.95 radians per second. That's the angular speed just at t equal to 2 seconds. Then you are ready to calculate the radial acceleration. This one you use the t equal to 2 seconds. So use that number squared, then times radius, just 0.305, 61 centimeter. For radius is just 0.305 meters. Okay? You get 130 meters per second squared. Okay, so we need to calculate the tangential acceleration. So that's just relates to the angular acceleration times the radius, just like the speeds, just like the relation for the speeds. Angular acceleration we calculate here, 4.18 radians per second squared, then times the radius, 0.305 meters. So you get then the tangential acceleration is 1.53 meters per second squared. So you find in magnitude, the radial acceleration is much bigger than the tangential acceleration. 2 order magnitude bigger. 2 order magnitude bigger. Okay. Tangential acceleration is just increase the linear velocity, just increase the magnitude of the linear velocity. Centrifugal acceleration just change the direction of the linear velocity. Okay, so the next one we're going to talk about the 25 or the torque. Calculate the net torque about the axle of the wheel shown in this picture. So then the friction torque for the 6 meters Newton opposes the motion. So the question is you need to determine the direction of that torque for the friction torque, direction of the friction torque. The only way you can do is you first determine the possible direction of the rotation of that wheel. You need to first determine the possible rotation of that wheel. Then you can determine the direction of the friction torque. Okay? The direction of friction torque is just opposed that direction of the motion of that wheel. So this wheel is under the action of the three forces. So basically you need to calculate the torque of the three applied forces first. So you calculate the torque of the three applied forces first. It's 24 centimeters. This is 12 centimeters. This force just this way. Second force this way. This force this way. 18 newtons, this is 35 newtons, this is 28 newtons. Okay, you need to calculate the torque by the applied force. They apply the three forces. Here is the convention. So if the rotation is clockwise, so that direction we can notice there's negative. If the rotation is counterclockwise, that direction usually defined as the positive direction. So we look at this force. So this force is just tangential to the rim of this circle at this point. So that torque by this force should be this force times its moment R. The moment R is measured from the rotating center toward a perpendicular line to that force. So in this case, just this line. So that distance just measured from that center to that point. That's called the moment R. For that force, this moment R is 24 centimeters. So that torque is just that force times that moment R. For the direction of that torque, you look at that force is going to rotate this wheel clockwise. So that torque is negative. Use negative side, 18 newtons times 0.24 meters. That's the torque for this force. It's negative side. That's because the rotation by this force is clockwise. For this force, 35 newtons, let's also rotate that wheel clockwise. It's also negative. The moment R is just the radius of this circle, 12 centimeters. So that torque should be negative 35 newton times 0.12 meters. Then the third force is upwards, so that force will try to rotate that wheel counterclockwise apparently. So that torque should be positive, 28. Moment R is 24.24 meters. Then calculate, we will get the total applied torque should be negative 1.8 Newton meters. So the total applied torque is negative. So that means the total applied string force try to rotate this wheel clockwise. They try to rotate this wheel clockwise. So that direction of friction torque should be opposed that direction. So the direction of the friction torque should be counterclockwise. So the torque by the friction counterclockwise, so it's positive, that number, 0.6 Newton meters. Okay, that's all the torque. Then you can calculate total net torque. Total net torque is just those two and together. Just negative 1.8 Newton meters times plus 0.6 Newton meters. Negative 1.2 Newton meters. Okay, total net torque is just in magnitude 1.2 Newton meters, where the negative side gave you the direction. Total net torque is still clockwise. Still clockwise. Try to rotate this wheel clockwise. Okay. So that's all the problems. Pressing?
Yes. Can you do wrong from chapter 6? If you can quickly.
Chapter
Probably 49.
49. Chapter 6?
Yes.
You mean 49?
Yes.
Okay, a 145 gram baseball is dropped from a tree 12 meters, that's the problem? Above the ground, with what speed would it hit the ground if the air resistance would be ignored?
Yep. Part B of that.
Yeah, okay. So if they actually hit to the ground with any speed, then what is the average force? Okay. So that's the one we're talking about the work done by a non-conservative force. So the ball is dropped from that height to the floor. The height is given, right? The height is 12 meters. That ball M is 145 grams. That will hit the floor with that speed. If the final speed, they tell you if the final speed is 8 meters per second. You just want to do the second part, right?
Yes.
Okay. So what's the friction? Okay. Because they have the friction from the air, so the force on that ball, two forces. One is gravity and G. One is the friction, okay? Friction is upward because that opposes that motion of direction. Ball is moving down, so that friction is up. And so there is the formula for that. The work done by the non-conservative force, equals the change of total mechanical energy. We talked about this before? So this is the formula you need, actually. The change of mechanical energy is just the mechanical energy final point minus mechanical initial point. I think I derived this formula before, but anyway, we just use this first, then we maybe talk about the derivation. If we use this, the only non-conservative force is just the friction. The gravity is a conservative force, okay? So only non-conservative force here is just the friction. So the work by the non-conservative force, just by this one, from this point to this point, the displacement is just the edge. Initial point right here, final point right here. Initial, final. So the displacement is just the edge. Okay? So if we choose whatever direction, if we choose the upward direction is positive direction, then the displacement is negative. Okay? The displacement is negative, then that means negative 12 meters. Okay, here. Then the force is positive because force is up direction, positive direction. 3 times the force, that's the work done by that force, F. Then equals this side, final point energy minus initial point energy, final point right here, final point total energy, kinetic energy, just the speeds, potential energy, we choose this point as 0 point, so potential energy is just 0. So minus the initial point. Initial point's speed is just 0. So kinetic energy is just 0. You just minus the potential energy. Potential energy is just the n, g, then h. Okay? So you get, so this one you will get, you can cancel the n, okay? Don't worry about the n. So here is just a half times this one. This one is given this time, 8 meters. So that's 8 squared minus g times h, 12. Okay? Then this one equals 12 minus 12 times f. Then f equals just those things divided by minus 12.